As you know, he's one of the organizers, and in every event, all the organizers are equal, but sometimes one of them is more equal than others. And for everybody who's benefited from Andrzej's powerful organization and hospitality, I would like to thank you for all of us right now. So please. We all know his work about Pollock, but now we all want to hear more about Klee's notebook. So thank you, Andrzej.
So you prevented me from saying.
Just a minute.
Sorry.
Okay. Thanks, Robert. You prevented me from saying thank you to the organizers. This is a very different kind of look at art, and a very preliminary project. I call it slightly naive, more to be done. In some sense, sort of a first look of this kind, perhaps, at the notebooks of Paul Klee. I want to start by noting that abstract art spans a great range when it comes to how well prescribed it is versus how much it allows natural phenomena to contribute to it. So at one end of the spectrum, you have paintings that are severe in certain sense, mathematically, very highly controlled, perhaps rectangular, as in Mondrian. He never used anything else but rectangular geometry. But there are other people who've filled the void, so to say, Kandinsky, for example. So these two are severe, although Kandinsky less severe, and many other of his works much less severe. And then there are people like Leger who are using various geometrical forms in a sense as a language. So they're not as severe in that sense as, say, Mondrian. So this is one end of the spectrum. The other end of the spectrum is when the artists allow nature to play some role, when there is a dialogue. And you've just heard a very nice talk with 3 examples of that. Here are a few more at this end of the spectrum. Maurice Lewis used gravitational flow in the folded canvas, as shown in here. Motherwell used various kinds of sprays where you can see the capillary breakdown of streams of jets, sort of caught in flagranti, so to say. And to just give one more example of that obscure painter, Jackson Pollock. By the way, one quibble I have with my dear friend Roberto is on the use of the word drip. Pollock disliked the word drip very much, as is well known. And the better word is poured. He poured in a certain way rather than drip, although there are some drips in his paintings as well. So these are the 2 extremes. And I want to offer a thesis that Paul Klee attempts to synthesize these 2 extremes together. That is to say, that he wants to maintain an abstract idiom, language, but in the same time to capture something about nature. Where is this thesis coming from, you might ask? Well, it's coming from him. He said, I have succeeded in directly transposing nature into my style. So I want to examine this claim in a sort of naive way by looking at his notebooks. Before I do this, I better say a few words about dramatis persona. He was a Swiss man, but had a German citizenship, and spent most of his life in Germany till the Nazis came to power, closed the Bauhaus school, and he emigrated just before things turned really horrific. He served in First World War, and interestingly enough, by this time he was very prolific in his painting. By the way, he left about 9,000 works of art, so it is enormously prolific. Anyway, as you can see, he found something to do in the Prussian army. But I want to focus on, for obvious reasons, on the period when he was teaching in the Bauhaus schools, first in Dessau and then later in Düsseldorf. That's about a decade, 21 to 31. For one thing, the notebooks that I'm going to look at with you are for his teaching in Bauhaus. And so they call to this period, to this Bauhaus period. But before I do this, there are two things that any talk about Klee must include. The first is that he was an incredible lover of cats, and here he accompanies the cat Bimbo. There are many paintings in which he expresses his love of cats, so this is one of them. The second thing is that he was actually an accomplished musician and lover of music. And here in his Munich years, he's about 21 here. He's playing the first violin, but strangely he's sitting on the right rather than the left. This is in his studio, and notice that instead of music stands, there are easels, painting easels. Anyway, he played violin till all his life. Okay. So here's information about these notebooks that I'm going to look at. They were sort of collected and collated and published in German first. In 56 and 70, I am using the edition from 73, and they essentially represent the work done between 1921 and 24. They're available online. I don't think there's copyright on them. I hope not. But anyway, there are many places where you can look at them, and here's one of them. Okay, so the marching orders for this are that there'll be 5 short pieces here, namely something about line that we've heard a slightly different take from Alan McRobbie, about form in 2 and 3D, growth, motion, and order and disorder, I suppose. So part 1, lines. This is a well-known quote from him. So I'm going to show you a little bit from his notebooks with the reference, and then try to extract something from it. So one of the things that he's done a lot on lines is, this is one of the recurring themes, is to discuss the form of lines. And here is in one place, volume 2, page 16. He collects various kinds. Here is his writing and translation. Note that these 3 are in fact coiling-like, so they allude to Roberto's talk. And if I may sort of use something from my own paper, here is a superposition of translation and rotation characterized by Strohal number, which is the translational speed divided by essentially rotational speed, but normalized through the radius. Anyway, so you can see various possible shapes. Here is something that begins to look like sinusoidal, but not quite. And you can see that these are represented here. Spirals, which are important for this program, are appearing many places, so I thought I would show you something about this. In particular, he writes here in larger letters, variable radius lengths combined with peripheral movement transforms a circle into a spiral. This is correct. And in fact, this is a logarithmic spiral. Here is the expression for it that captures this. Here is one other of many analysis of spiral, and here I want to bring your attention to this little bit here, where he says that the radial movement or progression per rotation is like 1, 2, 4, 8, and so on. In other words, that R of n, where n is the number of rotations, goes like 2 to n. This is in fact correct, as you can easily check by, for example, choosing these particular values of A and B in this formula, and you're going to get this. So this is in fact correct. And perhaps in here, he is analyzing an involute, which I am showing here as well. Well, here's a painting from just before Bauhaus period showing a spiral. He's indeed employed this form. And here, an image dear to GFS, which is our spiral, the Nautilus shell. There are many other lines being analyzed in the notebooks. I'll just show one more with an appropriate quotation. And in here there is an attempt to relate this line perhaps and some movement of it with some energy, etc., etc. And it has been encapsulated in this painting. The one thing to say about this is already, you can see here what I mean by synthesis. This is in some sense an abstract painting or nearly abstract painting. There is obviously, you can see a snake's head here and so on, but it's taken far away from what nature would look like, really. It is really a process of analogy in some sense, a thinking analogy. All right, form in 2D was appropriate quote. So here's a page from the notebooks where on this page he talks about creating 2D objects from linear displacement of 1D objects in various geometries. And here a slightly different take on a point and a line being in a relationship. I think after Alan Roby's talk, I'm allowed to use the word eros. So there is a tension, he says, between these two, and this is how a triangle is created. And this painting, perhaps, from the year when Klee was forced out of Germany, illustrates, I think, some of the tension of the simple shapes, triangles, circle, and others. One of the very frequently recurring themes in 2D, so to say, are what Klee calls structural formations. You can see this here, but what I will call tilings. And you can see some examples in here, familiar things, including checkerboard. And indeed, there are many checkerboard paintings of various kinds and various variations on this. You could give a talk just on this alone. Here is perhaps the best well-known of these. It's called Super Chess, but there are many others. There's been he also used an analysis of the colors to use, and here numbers on the left-hand side represent colors. And he says square structuring, by which he means this, I suppose, and maybe this, can be accomplished in color with two elements, i.e. two colors. And that is indeed so, as we know from just looking at chessboard. But here is a more interesting implementation of this idea, although an argument could be made that there are three colors here. Which brings me to the sort of idea of the four-color map theorem, which in many of his works Klee seems to be touching on. Here's one such painting. If you allow for ocean and lake, so this is the ocean, and this may be a different depth of the ocean, and this may be a lake. If you exclude these things, and there are five colors here with some allowances, and I've searched long and hard to find four-color map in his oeuvre and didn't find it, but clearly this was a subject that interested him, and there is quite a number of comments about this in his notebook. And this I include only because this is a very nice two-dimensional, so to say, painting which imitates a mosaic. It's called The Memory of a Bird, and if you perhaps you can see that there's indeed a bird there, or a shadow of one. But another example where there is a fine line between complete abstraction and, to use the word, memory of some natural processes. Now for something closer to this workshop, we had this program. We had a workshop, in fact, on shape transformations, and here is a page from volume 1, whereby he, in fact, shows a deformation of the rectangular coordinate system successively, which deforms some two-dimensional shape in a way shown approximately. And of course, I couldn't resist juxtaposing this against the Darcy-Thompson way of doing things, but in this case also Thompson's drawing of such deformation against Klee's drawing. So he was been thinking about coordinate transformation and transforming shapes as well. And this is a painting where perhaps you can see some of this kind of transformation used locally from the Bauhaus period. Okay, form in 3D. This is a well-known quote from Klee. Nature is garrulous to the point of confusion. Let artists be truly taciturn, simplify, abstract. And this is one of many paintings that tries to capture something about 3D space in a fairly abstract way. Well, there are a lot of pages in the notebooks with these kinds of things. Apparently, Klee discovered Cartesian coordinates, but also thought about representation of things in 2D by 3D by shading and so on. But here's a painting which plays on such. One of the great interests of Klee was blurring the line between inside and outside. There are many pages devoted to this issue, inside of things and outside of things. And here's one painting that tackles this question. And then there's projections, by which Klee means that if you start with some figure on a flat grid on a plane with these squares numbered here, then if you deform them, the grid, to be a three-dimensional, then if you project this shape, this is what you're gonna get. So it's a projection on a deformed ground. And here is a painting, not exactly about this, but it clearly shows thinking about projecting things from one space to another. There's also a great deal on honeycombs. This is one of the pages that deals with this. And here's a more regular one, and perhaps he was alluding to honeycombs in art more generally. This is a well-known old theme going back to Greeks, and here's an example, a particularly striking example from the 2nd century BC. And to finish this part, here is a very nice painting that shows this process that I'm talking about of abstracting something from the real world. It could just be very nearly abstract, except that there is a sense of 3D in it. Okay, a little bit on growth. And here is another quote where Klee brings in nature. So you find things like this in notebooks. By the way, the things are quite disorganized. If you follow my numbering here, these references, you will see it jumps all over the place. So it takes a little bit of effort to organize these things. But in any case, this reminded me of a page from Areski Boudoir's talk showing local deformation in growing leaf. And here's another one, and a painting that seems to have come out of this from the Bauhaus period. And I want to make this point again, and this time a little more forcefully, by subverting this painting a little bit and showing it on the side. And here you can see that while it is capturing something about nature, it is as nearly abstract as one can in this context. And there are things like this. There are studies of branching, which is a topic dear to Christoph Eloy here. And these lines represent growth, the thickening of the trunk and of the branches. And you can see it in some of his paintings as well. And here's another take on growth, where you can see essentially annual rings, if you want, in plants and things. And indeed, there are many paintings. This is one of them where such can be seen. This is called Time and Plants. And you can see in many of these structures these kind of expression of growth. He called it natural growth, so I quote it as such. And many pages on form creating nature, where these hatched lines represent the direction in which things grow or expand. Whoops. And here is a painting where you can see such in here, for example. Good. So now we're into motion. By the way, like Pollock and many other artists, he was preoccupied with capturing motion in static medium, which is painting. And he starts with, also starts as a funny word because it's near the end of the first volume. He starts with very simple devices and like pendulum, and shows the varying speed through the thickness of the line. So it's developing basically a language to capture this. There's a sentence right below here: gravity and momentum are closely related. I will leave it without comment for this audience. Of course, he's basically thinking about the velocity vector, and perhaps about acceleration vector as well in this situation. Here's a more interesting thing that surprised me greatly when I found it. There is a picture what appears to be a projectile motion with air resistance, some analysis of it, and then this, which I take to mean that there is a bouncing ball on a curved surface. And so here's the real McCoy when it comes to projectile motion with the simplest kind of air resistance of this kind. And of course you can solve it easily. This is an exercise for a freshman physics class. But anyway, these are the shape you get, and you can see that he captured it quite well. In here, of course, the angle is kept constant, but the speed is varied. And as far as this is concerned, I'm just only showing what happens if you bounce perfectly elastically a ball down an incline at some angle. This has slight curvature to it. And this is a nice exercise to show that, in fact, the ratio of these things goes like this is twice this and so on, which seems to be more or less reproduced here. And this property is independent of an angle, actually, of the incline, as you can verify.
Unless it's 90 degrees.
Well, yes, or minus 90 degrees. Correct. And there are things like this, which I take to be a dynamical system on a circle, maybe reminding one of something like a circular billiard and so on. Okay. And 2 more pages on motion or movement, and especially this part where he says in terms of space and time, shifts of measure and weight. Perhaps he means center of mass or here, based on shifting centers. Well, here is the center. So here is one rendition of it and some other renditions of it. And there are many, many paintings that implement this. This one is my favorite of this group of paintings. Again, sort of middle of the Bauhaus period, and you have a sense, at least, of dislocation in strobing time. This may be an allusion to a master of this kind of effect, a futurist, Giacomo Balla, who used it in many of his paintings. This is one example of this. Okay, and this is the last part on order. And here is, to start it, a page where there's some chaotic trajectory and some more organized. He writes here cosmic for the chaotic, and this is cosmic, and so on. And so for this, I'm choosing actually a fairly well-known page from the second volume of the notebooks, showing, this is called Movement in Locks, showing presumably a flow which starts laminar and then develops some waves and perhaps turbulence. And here is, this is the direction of flow. This is, for comparison, a different kind of flow. This is a transition from laminar to turbulent over flat plate for very high Reynolds numbers. And, well, this is the flow direction, the same. And you can see here laminar and perhaps Thommen-Schlichting waves, and then turbulent flow as well. But there are, you can find examples that more nearly represent what Klee had in mind. And then all of this is abstracted into this kind of thing. It's called in the current, in case you wonder. This is now sort of almost Mondrianesque, and yet it has something about physics in it. And in particular, if you look, for example, on this strip, there's 1, there's 2, there's 4, and so on. So it begs the question, is this period doubling sequence? As, for example, in logistical maps, whereas you know there are 2 Feigenbaum numbers that this first one shows the position for some parameter A here of the bifurcations and so on. And so I indulge in a little exercise of picking this strip and actually measuring in some units the positions of these transitions, and one more here, and then calculating what would have been Feigenbaum number, but it comes out to be about 1.2 or something, so perhaps this should be called Klee number. I'm sort of a little facetious here because what Klee really had in mind here is a golden section, which was just mentioned moments ago here by Alan, I think, which is this. And for example, if you take, in my notation, A4 over A2 is basically it. So, and he's learned how to construct golden ratio scenarios. And I finished with this picture that after the discussion I've alluded to here, you can see why this in fact is motion near the coast, that it's an abstraction of this idea of these thresholds, some waviness. In some sense it's fully abstract painting, but it carries a shadow of something that happens in nature. So I want to make remarks about this, 3 remarks. First of all, the notebooks are a trove of geometrical and physical ideas aiming at synthesis of natural and mathematical forms. And I don't think they've been taken too seriously by physicists or mathematicians before. Form, growth, and representation of motion in static mediums are recurring themes. In some sense, they are a key to many of his artworks. And Klee's geometrical constructions, coordinate transformations, projections, and something I didn't talk about, I had to cut a lot of things out, obviously, but he devotes a lot of time to perspective, reveal an analytical and highly disciplined approach behind what many people take as completely childish or spontaneous, unthoughtful art. But I have to end with a warning here, and a last quote from Klee. And the warning is that he said, the worst state of affairs is when science begins to concern itself with art. So I want to thank Claude Czernuski, my collaborator on Pollock thing, for the idea of looking at Klee, and thank you.
Is that the worst state of affairs for science or the worst state of affairs for art?
I have to leave it as it is without elaborating on it.
Okay. Yes, Stephen. Can I, Jane, you want to come and set up when Andrzej, yeah, go ahead.
It would seem kind of amazing to me that all this time working at Bauhaus, he wasn't talking to mathematicians or anybody, or just for that matter.
I was thinking about the same thing for a long time.
Who's talking to while all this?
I don't know, and this is actually a question very much in my mind. There may, obviously, I didn't show you many places where there's some silly things written about mathematical formulas and so on. But so he didn't have a formal education in mathematics. I don't think he talked regularly to mathematicians, but maybe. So
That's kind of a shame.
yes, it's a shame that he didn't.
Shame on the mathematician. Maybe.
Yeah.
Okay, right, thank you. One of the interesting aspects which came to the surface in a few places in your talk, what we are looking at is a two-dimensional set of marks on a two-dimensional flat surface, where our minds have a tendency to extrapolate that to a three-dimensional image. And the classic example is the Necker cube, of which did occur in one of Klee's things. If you had, you're not able now to sit back. So, going further back in your talk, there was an example where he had drawn not rectangular but oblique cubes.
Entailing section.
Yeah, to, as it were, force a three-dimensional impression of curvature on you. And so my question would be, to what extent do you know whether or not he consciously thought about the tendency of the mind to build three dimensions onto two dimensions?
Oh yes. He thought about it a great deal, and indeed, these are. I didn't really read. Oh, you have to get the book and look. But this is very much on his mind, and this is why all these examples are there. So absolutely, he was thinking about this. Remember, the first volume is called the Thinking Eye.
Yes.
I guess my question is a follow-up of the previous one. He never got interested in 3D. He never did sculpture.
Oh, to my knowledge, no. A very interesting question. He worked in 2D, and but there is a great variety of work that he did in 2D. I've only showed you a very small window on some period, the Bauhaus period.
Okay, well, thank you again for this.